This video is going to teach you about function notation. This is by far one of the trickiest sections of this unit. So I want to make sure that you understand everything that I'm telling you. First of all, you have to remember what a function is. So a relation, or a set of ordered pairs, or a graph in this case, is a function if each member of the domain, that's your x values or your input of the function, associates with only one member of the range, which is your y values or the output of your function. So just as a test of your memory here, I have two equations that could be graphed. One of them is a function, one of them is not. Do you remember which one is? Just testing your memory. Hopefully you say this one is, because it's a horizontal line and it passes the vertical line test. In fact, if it's linear or straight, which all of the equations that we're working with in this unit are, and it's not vertical, which is what this one is, then it's a function. So in other words, everything we're dealing with here is going to be functions, okay, except for vertical lines, and that would just be x equals something you have to remember, okay? Let's move on. Function notation. Now, the way to write an equation in function notation, you want, first of all, okay, an equation, a function notation is just a way of writing it that represents a function. So what you need to do is first make sure that it's in function form, and you do that by solving for y. And then what you want to do is replace the y with the name of the function, and it's usually that f of x that you see off to the side here. Okay, we name functions with f and g usually, but that's what you would do. So, for example, I have here an equation, y equals 2x plus 1. This is a linear equation. It's straight, so it is a function. If I wanted to write it in function notation, let's say I wanted to name it f of x, like this over here. Okay, then what I would do is I would just take this y and replace it with f of x. And I would say equals 2x plus 1. Again, this whole thing is read as f of x. Okay, that's how you would say that. Now, this is the name of your function. Oops, I was going to put name. This is your name of your function, so it's f. The x here is the input value of your function. And then this whole thing would be the output value of your function. Okay? Functions are usually named, again, with an f or a g. So this one is f of x, you could have g of x, and I've seen others, but those are the main ones that you're going to see here. Now, I know some of you are asking, why have function notation? It doesn't even make sense. Why would you want to do that? Well, you want to do that because this way you can use more than one equation or function at a time without confusing the variables. So for example, if I was graphing two equations and I was talking about y, and you're wondering which y are you referring to, you say, oh, I'm referring to f of x, or I'm referring to g of x, or I'm referring to, and you can graph multiple things or talk about multiple equations that may share the same variable, but it's a way of differentiating between which one you were talking about. That's why we have that, okay? Now, after that, as long as you're comfortable with that, let's see if we can use this f of x equals 2x plus 1. Okay, some of you are saying, well, how do we use it? Well, you may be asked to find a value. So you'll see something like this. Find f of x when x equals 5. What this is saying is when 5 is your input, what is your output? So, in other words, what we would do, okay, you can write it, by the way, written. If we wanted to write this thing, we would take this value that was given and we would put it into here, saying f of 5. So in other words, when 5 is the input, what would the output be? Well, again, this side is the output. So what we would have to do then is take whatever value is here that we're trying to evaluate. We're trying to find f of 5, and we would put it in for x to find the output of the function. And this is equal to 11. So in other words, your answer would be when x equals 5, f of x is equal to 11. Okay? One way you can think about this is, all right, x is 5, y is 11. Okay? That's one way you could think of it. But it's, you take the value for x and you say, all right, what would be the output of the function, or what would the y value be, is one way to think of it. Okay? So I'm going to give you a couple more examples here. Here I have the exact same function. F of x is equal to 2x plus 1. I want you to pause the video and find f of negative 2. And then I'm going to challenge you to see if you could find the next thing. So in other words, when f of x is equal to 25, I want you to find what x is. Okay? So pause the video and see if you can figure these out. Okay, for the first one, f of negative 2 is equal to 2, and I'm going to put the negative 2 in for x, plus 1. This would be equal to negative 4 plus 1, which is a negative 3. So when x equals negative 2, f of x is equal to negative 3. In other words, when x is negative 2, y is negative 3. Okay? Now, what's different in this next one? Here we have f of x is given to us. So in other words, this part is given to you. The y is given to you. We need to find x. So what you would do for this one is you would set it up like this. 25 is equal to 2x plus 1. And then you would solve for x. So it's just the opposite of the other one. Subtract 1 from both sides. We have 2x is equal to 24, divide by 2, and x is equal to 12. So for this one, you would say when f of x is equal to 25, in other words, our output was 25, or y is 25, x, or the input, is 12. Okay? Cool. Let's try graphing. If you were asked to graph a function, this isn't a big deal as long as you think of that f of x part as being your y, because then you would look at it and say, oh, well, it's in slope-intercept form. And I know that right here is my intercept, so I can go onto my graph, and I can graph 1, and then I know that 2 is my slope. Now that can be written as 2 over 1, or it could be written as negative 2 over negative 1. Let's use both. The first one, 2 over 1 means go up 2 to the right 1. Up 2 to the right 1. The other one says go down 2 into the left 1. So down 2 to the left 1, down 2 to the left 1, and they line up still. And there is our graph. That is the graph of f of x equals 2x plus 1. Not too bad? I don't think so. Alright, moving on. Last thing. Excuse me. Now, here what we're doing is I want you to write a function f, given that f of 0 equals 1 and f of 3 equals 7. That should not be a big deal. Remember that here, let me write this point down. So first one, you have f of 0 is equal to 1, and we have f of 3 is equal to 7. So what you need to think of here when you're is what point, what's your x and what's your y. This is something that a lot of students get confused, okay? Remember, we need our x value, we need our y value. This is the input of the function, which is the x value. It's your input. This is your output, which is your y value. So you could look at it as being set up like this. Okay, so then for our slope, m, we would take our y values and subtract them. So that 1 minus 7, we would take our x values or our inputs and subtract them. 0 minus 3. And you could have done this other way around, 7 minus 1 over 3 minus 0. That would work as well. Negative 6 over negative 3. Our slope is 2. So we want to call this, it says write a linear function f. So that means, all right, f of x. So instead of saying y equals mx plus b, it's f of x is equal to our slope, 2, and our x. And then what is our intercept? Well, remember that our intercept when x is 0, our y value, or our output of our function, which is our y value, is the intercept. So we have plus 1. Okay? You may have to watch this a couple times to make sure that you fully get it, but I highly recommend that you do. Okay? Goodbye, my friends.